Alright, hello, Mr. Beeland here with your science lesson for today. Today we are talking about balancing chemical equations. Alright, so our goal here is to have the same number of atoms for each element on both sides of the equation. Remember, we have the law of conservation of mass that says that the number of atoms or the mass on the reactant side has to be the same as the mass on the product side. So, whenever we have a chemical equation, we need to make sure that it's balanced. We can't lose anything. So what we can do is play around with the coefficients. We can adjust the coefficients. In a reaction, we cannot adjust the subscripts, right? Those are set, right? For each molecule, they'll need a certain amount of atoms of each element in order to be there. And if we play around with those, it's a completely different molecule. So the only thing we can do is change around the number of molecules. So we can change the coefficients. Balancing an equation takes 4 steps, okay? So step number 1 is to write the chemical equation without any coefficients. We just put everything down on the reactant side, everything down on the product side, and it's called a skeleton equation, okay? It's just the bare bones. Once we've done that, we can then count the atoms for each element on each side. Okay, so we're going to count each element on each side, and then we choose coefficients to try and make them equal on both sides. Whenever you have an odd number of atoms on one side and an even number of atoms on the other side, a good hint is to always just double the number on the odd side. This is because there's no way to turn an even number into an odd number with whole numbers, right? So turn the odd number into the even number. Anyways, when we mess around with these coefficients, sometimes when we increase one thing, it will change another, right? Because molecules come in pairs sometimes, or 3 elements, or 4 elements, or whatever. So we try to double one thing and it may end up increasing something else, and we might not notice. So we always have to make sure to recheck and then possibly do some more balancing afterwards. So we go 1, 2, 3, check, and if it's good, we're finished, but if not, we might have to go back to 3, and we just have to keep looping back from there. Okay, so what does this look like in practice? So for example, I have sodium bromide and I have chlorine gas. And there's a reaction where we end up with sodium chloride and bromine gas. So this is our chemical equation. This is step 1, right? Just writing it down like this. Nothing extra. Then step 2, here, I'll even put a 1 here. Step 2 is to count the atoms on both sides. So we start with Na, we have 1. Na, we have 1. Br, we have 1. Br, we have 2. Cl, we have 2. Cl, we have 1. Alright, so Na and Na, those are both fine. Bromine, they're not equal. So how do we turn a 1 into a 2? We can times this by 2. When we do that, 2 is going to go up here. Okay, now let's look and see what happened here. When we do that, that changes this into a 2. Well, now these numbers aren't equal. So how do we turn this one into a 2? We do the same process. We have the 2 here. Which means we have to put a 2 up front here, because that's where the Na is. Now we can have a look. We see we have 2 chlorine atoms here, and because of this 2 here, we actually do have 2 chlorines there. So again, one last check. 2, 2, 2, 2, 2, 2. This is a balanced reaction now. So step 3, balance as 2Na Br plus Cl2 2NaCl plus Br2. All right, so this is a pretty straightforward example of how to balance chemical equations. Next week, we'll start looking at some that are a little bit trickier, but for now, work on your interactive notebooks and work on your practice exercises to start getting this down. All right, take care, everybody.